Hello everyone and welcome to IS688, a course on web mining. I'm Cody Bunton, and in this set of slides and lecture we'll talk about introductions and course logistics to kick off the course for the semester. So first off, as I said, welcome to 688, a course on web mining, section 852. In the spring of 2021, given COVID and the existing state of the world, this class will be offered online and asynchronously. So if this is not the course you expect, I'm a little confused as to how you came across this video from Canvas, considering this was posted to the 688 Canvas course, and it should be relatively clear what class this is. But if you are just here to enjoy, then by all means sit back and enjoy. So first off, who am I? So as I mentioned, I'm Cody Bunton, professor in the informatics department. This is my second year at the university, and prior to that I was at NYU, and I got my PhD from the University of Maryland, where I then went on to become an intelligence community postdoctoral fellow, working for the National Counterterrorism Center and the START Center at Maryland, or the Center for Anti-Terror Research. And as I mentioned, I was at NYU prior to coming to NJIT, where I was getting my postdoc at the Center for Social Media and Politics, which used to be called the Social Media and Political Participation Lab, which is part of the Center for Data Science. Prior to getting my PhD, I was also the director of research for a small cybersecurity defense contractor that was then bought out by Raytheon. And then in terms of the kinds of work I do, my lab is the Information Ecosystems Lab, and I work on a number of different areas, primarily related to social media and crisis communication, social movements, political participation. As part of this, I do a lot of work on text mining. I work on distributed and cloud computing, machine learning, and network analysis across a variety of platforms, from Facebook to Twitter to YouTube to online news, basically anything that exists in the online information space. And more recently, I've been doing work on mis and disinformation as a follow-on to my work on rumor detection in the aftermath of crises. Outside of my research, I enjoy movies. These are some of my favorite movies: Hackers, The Matrix, and The Fifth Element. I have a motorcycle, though it's been a couple of or several weeks since I've ridden it, since I last rode it in December when it was snowy, which is a terrible idea. And I also enjoy board games. In particular, Mysterium is one of my favorite board games. So this is some ideas about who I am, both within and outside of work. In terms of my general approach to teaching, I try and be relatively laid back, though I do expect you to do the work for the class. But overall, I am not a hugely strict professor in terms of what you call me or our interactions, these kinds of things. And you'll see that throughout both this lecture and the course in general. If we were in person now, I would take the opportunity to ask you all to introduce yourself. I tend to prefer in-person learning, but again, the world given what it is, we are in an online world now. Though hopefully by the summer and the fall, things will be back to at least more normal of a world. But in lieu of in-person interaction, I have an introductions discussion board on Canvas that you should visit as part of your participation grade, which we'll talk about in a few minutes, where I ask you to introduce yourself and a few things about you. During the course of this lecture and the class overall, I'll note a couple of things on etiquette. I have this set of slides in all of my classes. This one in particular, for the web mining course, since it's more of a technical course and less of a discussion and socially oriented course, this may apply less, but still, controversy is part of debate when we're talking about how systems work, or ideas for projects, or what the ethics are of collecting a lot of content from online sources. You know, there's a lot of potentially ethically loaded or controversial content there, such as opinion mining and what kind of preferences people have. when we engage with these kinds of conversations, it's important that all of you remain respectful and supportive during discussion. And this is especially important during controversial discussion. I want the classroom to be a place where we can have potentially controversial discussions and reach some consensus, or at least respect that other people have different perspectives. So it's particularly important now, given the current political climate, where there are a lot of concerns about the role of technology in online discussion. Also, in terms of etiquette for your professors, when referring to your professors, generally the safe assumption is to use their title and last name. So for me, that might be Professor Bunton, regardless of gender, or what your assumed, or what you think the assumed gender identity may be of your professor. It's best to stick with Professor Bunton. For me, though, this will be the opportunity for me to say otherwise stated. You're free to call me Cody or Professor Bunton or just Professor. I don't hugely care so much about the title. So that's an introduction about who I am, give you the opportunity to talk about who you are. Let's talk now about some course materials for 688. So there is a textbook for the course. It is the Mining of Massive Datasets textbook by Yura Leskovic, Rajamaran, and Ullman from Stanford. It is freely available online at mmds.org. There's a number of resources available to you through this website. A PDF of the book at individual chapters, PDFs for slides, videos, these kinds of things. I'm not going to use the slides and videos directly. I will use some of the slides and edit them and incorporate them into my own work, but you are freely welcome to check out any of the videos. I will occasionally reference the videos or explicitly tell you if you want more information, go watch this video. This will be the textbook we use. In terms of prerequisites, there are 3. IS688, which is primarily programming. I think the title of that class is Programming for Informatics. The idea is for this class, you need to have some programming proficiency. I say a proficiency in Python is preferred, but the language of your proficiency is not essential. You're welcome to use R, Java, Ruby, Scala, or any other language that is at least moderately mainstream that I can understand or will not be hugely cumbersome to run or analyze for your semester project, which we'll talk about. There's also IS688, which is a databases course. The important points that'll be helpful for you here are concepts like tables, keys, and schemas. So this image on the right has 3 different tables with foreign keys and primary keys, and column names for the different fields in the rows in a database of these 3 tables. It'll be useful for you to at least have an idea of this kind of structure, especially for evaluating structured data or semi-structured data like JSON, or converting unstructured data like text into semi or fully structured data. The schema idea in particular will be useful. The idea of keys also will be helpful. And then depending on what you do, or some familiarity with the structured query language or SQL will also be useful. Not entirely critical for this class, but these ideas or at least concepts will be valuable or help you out. The last prereq in terms of classes is 565 or 665. It's a data analytics course. In particular, it's meant to help you or make sure that you have some background in statistics for things like hypothesis testing. So you can make claims or back up claims you make about data that you've collected to show that really, this type of data is sufficiently or significantly different from this other type of data if you're doing some sort of analysis like that. And then visualization is also an aspect of 665 that will be of value in this course as well, because one of the key tenets that we'll talk about around data mining and web mining is being able to identify and show interesting insights from large data sets. So being able to visualize that is a useful thing. Some other less class-oriented prereqs are proficiency in the command line, or if you call it the terminal or console, command prompt if you're more Windows focused. A lot of the work or examples that I will probably provide you will be available through Jupyter Notebooks, and being able to use the console to activate Jupyter and then work with content therein will be valuable to you as well. All of the course material is going to be available on Canvas. So as I sent many of you in an email yesterday, the course is now published on Canvas. I almost certain you know that, because that will be how you found this video, unless you just came across it on YouTube. I have all the modules for the class populated, at least loaded in, though the actual lecture and reading material is not loaded yet. That will be made available throughout the semester as we progress forward. Moving on from logistics to talking about what is 688. So first off, just from a high level, we can give you the course catalog description. That web mining, the name of the course, aims to discover useful information and knowledge from the web hyperlink structure, so the structure of the internet or structure of the web, page content, so we can mine content of web pages, and usage logs, so how are people engaging with the content on these web pages. Then web mining has direct applications in e-commerce, web analytics, information retrieval, personalization, recommendation systems, a number of these other kinds of technologies that are very popular now, and employees knowledgeable in these kinds of technologies are going to be highly sought after by web companies. Because primarily what we want to be able to do is understand user behavior and discover interesting patterns from potentially large volumes of data that are contained in web scale data sets or web scale data resources. We can be a little bit more grounded in this description, though. A while back, Popular Science had this cover about how data is power. There are some apocryphal anecdotes about how data is worth more than oil now. Data is extremely valuable, because the whole point is from data you can extract knowledge. But a key point about this class is that data does not necessarily equal knowledge. In order to be able to get at this knowledge, data that exists somewhere in the world must be collected, stored, and critically it needs to be analyzed. That through that analysis task can you extract the knowledge to make actions or make informed decisions about something. So in terms of the context of this class and other classes you may have, data collection is a lot of potentially web programming and access to APIs, which we'll talk about next week, just to give you access or get you some familiarity to being able to collect your own data sets from the web. Data storage, which we won't talk a deal about in this class, primarily will be things like databases. You can have your database class for row or column databases or NoSQL databases, these kinds of things, or data lakes if you're more familiar with cloud or distributed processing or distributed computing like Amazon Web Services or the Google Cloud, these kinds of things. And then data analysis for knowledge extraction. This is data mining, data science, really the core of what this class will be about. And then the web aspect, the web mining aspect, comes from large data sets that we pull from the web, rather than data sets you may build from sensors or like from your car or something like that. Though the world is increasingly, or the lines between those kinds of fields are becoming increasingly blurry with things like with concepts like the Internet of Things. So another point about what this class is versus what this class is not. So data mining draws from a number of different areas, from machine learning to algorithms and theory, from database systems. But critically, data mining is not machine learning. So when we talk about data mining, oftentimes we make use of machine learning or machine learning models, but the emphasis on what data mining is versus what machine learning is different. They both may be interested in extracting or learning some interesting insight, whereas machine learning is much more about training models and building algorithms that can recover behaviors or learn some interesting or embedded or latent phenomena in some data. Whereas data mining, or what we're going to be doing in web mining, is much more focused on extracting useful insights. And extracting insights doesn't always require some sophisticated modeling, and has a lot more emphasis on presenting that information, or a more human in the loop sort of mechanism where a human will be driving some sort of data mining process and then extracting those insights for business analytics or for decision making or something along those lines, and a less fully automated kind of approach that you may see with full machine learning kinds of systems. The course is broken down into 8 modules. Module 1, which is where we are now, we'll be talking about mining web data and motivations for this. We'll talk about in Module 2, explaining the web as a graph, or using concepts from network analysis and graph models to mine interesting insights from the web. Module 3 will be about measures of similarity in web content. So how can we evaluate whether a particular page is similar to another page, or more interestingly, whether a particular page is more or less similar to a given query, since a lot of similarity metrics in web content and web mining have been used for search engines. Module 4 will talk about hashing and dimensionality reduction. So one of the things you'll see when we talk about graph mining and measures of similarity in web content is you have potentially very high dimensional data based on what is the maximum size of a vocabulary you may have to describe all web pages in the internet. Well, that would be a huge number of columns in a database if you want to look at it that way, or a huge number of fields or features in a machine learning kind of system or machine learning kind of model. And that's often too much, right? So we want to be able to reduce those dimensions. Maybe you've seen this in terms of embeddings or PCA or something like that. That has a lot of value, both just in making things tractable, but also in terms of visualization or dealing with things rapidly or at scale, which is a valuable thing when we're talking about web scale data. Module 5 will talk about clustering, which is a nice segue from dimensionality reduction into clustering, but they're slightly different in terms of what their goals are, though clustering often may use dimensionality reduction or build on measures of similarity. Module 6 moves to recommendation systems, where we move from, rather than just building clusters of data or saying this content is less or more similar than this content, we'll talk about ranking systems. How can we, given a particular value, show you other things that are similar to or likely to be similar to your particular query or value, or show you people who are likely to be your friends or likely to have similar tastes than you or similar tastes as you, show you videos that are like other videos you've watched, these kinds of things, which are pervasive throughout the internet. Then we'll talk about Module 7, mining data streams. So the first 6 modules sort of have a static view of the web, where you take a snapshot of the web at a particular point in time. And Module 7 lets us move this forward into how do we deal with streams of data. So we know that new content is coming in to the internet constantly. People are posting new content to Twitter, new content to Facebook, uploading new images on Instagram, or new articles are being posted to the Washington Post website. All of these things, you can treat them as streams rather than just snapshots of data. Or you can do the same thing with log data from, say, your Amazon, and you want to process logs of what items people are looking at. And you want to be able to respond to interesting or people's interest in items very quickly. So you may not work on web logs from Amazon in terms of snapshots or in batches, but may instead process them as real-time streams, which requires a different set of kinds of algorithms and thinking. And then Module 8, the last module, will be about computational advertising. So advertising makes up a huge portion of internet revenue, so we'll talk about how that kind of technology works. A note on the MMDS. So the second chapter in this book focuses a lot on data sets that are web scale and providing scalable and large-scale distributed processing environments to process these large-scale data sets. Now, a lot of this is built around Spark and Hadoop, which are frameworks for allowing you to do massively distributed or massively parallel processing for dealing with web-scale graphs like the Twitter or Facebook graph, or the web graph that Google processes for its search results, these kinds of things. Now, we will not dive deeply into Spark or Hadoop or these kinds of more sophisticated technologies as part of this class, though I have a lot of experience with this. So if you have interest in using one of these technologies for your project, which we'll talk about in a minute, this is a thing that we can explore together. So the course also has 5 core learning objectives. The first is comparing, contrasting, and collecting static web content, structured data, unstructured data, usage data, and data streams. The idea is at the end of this course, you should be able to collect your own content from the web, compare different kinds of content, and then be able to describe and define why is static data different than data streams, these kinds of things, using data from social media platforms or large cloud-based databases like Google BigQuery, or pulling data from APIs like the list of public APIs that this nice GitHub repo provides us. The second learning objective is about converting un- and semi-structured data into more abstract data representations that we can then process. So taking text data, image data, link data from the web and converting it into vectors or matrices or sets that we can then use for modeling for downstream analytics tasks. Things like building networks of which websites are citing or linking to other websites, like the New York Times and Washington Post often link to each other. Maybe HuffPost primarily links to the Washington Post, but WAPO does not link back to HuffPost. Converting these kinds of structures or the content in these websites into matrices that are made up of terms and documents. How do we weight these terms and documents in a way that lets us account for extremely common language? So a thing we'll talk about, maybe you've been exposed to in like a natural language processing course, things like stop words that are extremely common words that have grammatical value but less informational value. So things like the, and, or, but, those kinds of words that are extremely common in written text, but maybe are not valuable if we're trying to provide a search engine capability or understand the topic of a particular document or a particular message. How do we deal with that and convert this sort of textual data into more structured kinds of representations? The third learning objective is about implementing and analyzing sort of standard or touchstone algorithms for doing clustering, dimensionality reduction, regression, or any sort of algorithm that we may use or apply to our data to extract the knowledge or interesting insights that we've talked about. For instance, this could be clustering or community analysis in a graph. It could be regression models. It could be, as I mentioned, dimensionality reduction, or anything along those lines. The fourth learning objective is about being able to extract insights from otherwise noisy data. So one of the important things about working with web data, especially large web scale data, is that often this data is very messy or has a lot of information that we may not care about, or a lot of data that's not useful for our particular task. So the fourth learning objective is about being able to discuss and evaluate which data mining algorithms are going to be most valuable for extracting some particular insight, or most applicable to a particular kind of noisy data. And then finally, the last learning objective is to work with a team to design and execute some sophisticated data mining project on data that's not already structured for your task. You'll be comparing and evaluating different design choices so you can make some claim about why, or at least justify why you chose what you chose, and sort of do this from an end-to-end perspective. And we solve this through a semester project where you get to work either alone or in a small team of other students to build some data mining pipeline through data collection, analysis, visualization, and presentation, which we'll talk about more in a few minutes. In terms of how the course is structured schedule-wise, so I talked about we have 8 core modules in terms of weekly breakdown. So this week and next week will be focused on Module 1. Week 3 and 4 will focus on Module 2, which is about treating the internet or the web as a graph and doing graph mining on that structure. Week 5 is about similarity. Week 4 is about hashing and dimensionality reduction. Week 7 and 8 are about Module 5, about clustering. Week 9 and 10 are recommendation systems. I guess 9, 10, 11 are about recommendation systems. Week 7 is about streams, and week 12 is about streams, Module 7. Week 13 is about Module 8 and online advertising. And then finally on week 14, we'll do final presentations from your project. And then the final exam will be substituted with the final project report, which will be due on May 12th. Note, for every module, I will have a set of associated readings coming from MMDS or some other freely available resource. Primarily, I will rely on the MMDS, but I may drop in a paper or a section from a different textbook, but I'll provide you with that material early on. It's important that you read the content that I assign prior to reviewing the lecture videos, is I will make the lecture videos under the assumption that you are already familiar with the content. So I won't do a huge amount of defining. I'll talk about much more about application or caveats or potential gotchas. I already have a breakdown of the chapters and modules in the syllabus or listed here. So mostly each module has a single chapter, though in Module 1 and 2 we combine a couple of chapters from the book. So I'll make this available and tell you which sections of these chapters to read. Other policies and grading distributions, that's what we'll talk about now. Well, the heading here is wrong. There are 3 parts to your grade, actually. The first is module assignments. So there are, I think, 6 or 7 assignments throughout the course of the semester that account for 50% of your grade collectively. So no single assignment counts for more than 10%. Then your final project is 40% of your grade, again, spread out over 5 different categories, or 5 different elements to the final project, which we'll talk about in a minute. And then 10% is about participation. A key point, a thing that I'm doing this semester that I've not done in the past, is I have a lax late policy. I will not assess any penalty for late homework or late submissions for the module assignments. Some of the research I've read on this suggests that these late penalties are not useful in terms of motivating you to get your work done, and in fact often are very detrimental to your grade. So my late policy used to be no more than 5 days, or any assignment cannot be turned in no more than 5 days after the deadline. But zeros in the grade book have a huge impact on your overall course average. This is not a useful thing, I feel, anymore. But the way you get to submit your module assignments, which I'll talk about, will be through Medium posts. So you'll be able to see, well, how many of your fellow students have also or have submitted their assignments so far, and what do they look like. So I encourage you to keep at least some amount of tabs on how the overall class is progressing. If you end up submitting all of your module assignments at the end of the semester, while it's not forbidden from the late policy, do note that if I have to stay up really late grading all of your assignments at the very last minute, and then you get poor grades on them as a result, you'll have less opportunity to work with me or talk about how to address your grades. In terms of the late policy for other assignments, though, I note that participation and the semester project assignment deadlines are more strict. Participation primarily because the whole point for the participation aspect is to get you to be more engaged over the course of the semester rather than waiting for everything at the end. And certain parts of participation in the semester project require you're working with colleagues or you're working with your fellow students, meaning that we have to do some scheduling or set aside some time where all of us are working on the same thing, which we'll see when I talk more about the semester project. All right, there are a number of other policies that you can review. The main one is about academic integrity. You are absolutely welcome to use resources like Stack Overflow or any online resource to get help or assist in your work. I'm 100% okay with that, but it is critical that you attribute where you got your work. So if you are submitting code, a comment that says you got this code from Stack Overflow or where you got this code, or if you are writing part of your Medium post that says what you did and how you did it and what the code looks like. If you are quoting from something, that's fine, but it's important that you attribute where you got the content from. If I suspect that you are cribbing content without correctly attributing it, I am required by the university to submit that information to the Dean of Students for review as an academic integrity violation. So nobody wants to deal with that. It's just much easier for you to say, hey, this is a quote from this paper, or this article, this Medium post. This chunk of code comes from this GitHub repo or this Stack Overflow posting. All right, the next thing we'll talk about is assignments. So as I've mentioned throughout this lecture, there are a number of module assignments over the course of the semester. There are 7 in total, though assignment 0 is a very straightforward one about just signing up for a Medium account. All of these assignments use Medium. The idea here is that by posting content in a public venue, that the quality of work tends to be higher, that the knowledge that other people can read your work tends to increase the amount of effort that students put in. And at the end of the semester, you have the opportunity to, or at least have built up a portfolio of interesting kinds of writing samples and code samples that you can then share. I actually have done this a couple of times in the past, and a number of the articles that have been posted to the class Medium posts have gotten featured on other article or other Medium publications, and have led to, I think, some interesting and valuable interactions for the students who have engaged with it. If you are unable to use Medium for some reason, it is imperative that you get in touch with me before Friday, January 29th. That's a week from this coming Friday, so we can work out some accommodation. You can see some examples. So as I mentioned, I've done this in the past. I did this last semester for my social media course. You can see examples at this medium.com/social media theories, ethics, and analysis for a number of different assignments and final projects. So you can see sort of what I'm expecting there. A colleague of mine at the University of Colorado in Boulder has done a similar thing in his information expositions class. So you can see what he's done and what his students have done there as well. And there are some other examples that you can check out. I have another set of slides about creating Medium content. I'll post those in the Canvas page as well. All right, so the next thing we'll talk about is the semester project. So the whole point with the project is meant to give you the opportunity to go deeper into a particular subject and a particular data set that you think is interesting. Because my experience has been, if you, the student, are interested in a particular problem and see the value or the reason to study a particular issue, you'll explore that much more thoroughly on your own than I could get you to explore in class. So there are 5 parts to the project. There's the project proposal, where you talk with me as the professor and create a team of your fellow students to solve some problem using some data set that you've collected. And there'll be some engagement back and forth between you and I about refining your project proposal idea. Then you will start collecting data for your project. Ideally, this will be collecting data from some API or scraping from some website to build up a large-scale data set, or use a data set that is large-scale but not crafted directly for your task. The third part is an intermediate report and review. What this will be is you create a report that says, the work you've done so far, the data you've collected, some preliminary analysis of that data, and that will be shared among all of your fellow students, or among a collection of your fellow students for evaluation, and be returned to you. Then at the end of the semester, you'll give a presentation on your work and cap everything off with a report, a final report on the project that also would go to Medium. A real quick set of ideas on the kinds of projects you could do. You can take some standard techniques that we've talked about in class and apply them to web scale data to extract some interesting or important insight. You can take a number of different techniques that we discuss in class and apply them to a particular data set or context, and then evaluate the advantages and disadvantages of each for some comparison. You can propose new methods of doing something or extensions on techniques that we've talked about in class to apply them to your data for faster analysis or higher quality heuristics or something along those lines. Feel free to reach out to me if you have questions or want more ideas or some refinement on your idea. I actually have a discussion forum on Canvas where we will discuss or can discuss and refine and go back and forth on some ideas. Note that your project proposal is due in almost 2 weeks, or a little bit over 2 weeks, on February 3rd. So it's important that you start thinking about what interesting kind of problem you may try and solve or try and address early on. So be thinking about who's in your group, what kind of problem are you trying to solve, where might you get data, what kind of technology do you want to use, what are you trying to extract from that, and why do you think this is interesting, and a couple other questions. As I mentioned, I have a discussion forum on Canvas where you can share some project ideas. I encourage you to go there, share an idea, use this space to recruit potential teammates. So by all means, you can post an idea here and your fellow classmates will post their ideas, and you can work together to decide, well, I like your idea more than this original idea that I posted, so how about you and I team up together? I will respond and give feedback to the ideas that are listed here. So post early. This is especially important since I'm asking you to propose project ideas before we've had a lot of time to go deep into the semester. So it's important that you post the ideas and have some back and forth with me, so you don't propose something that is not possible to do in the period of time that we have. So I'll give you some sample project ideas. One is to use some large-scale data set, like the Yelp Open data set, to explore some interesting kinds of questions, like predicting ratings for a given restaurant or for restaurants from review text. So using regression models or something along those lines to say, given this set of words in this review, how many stars are we going to give this restaurant? You can construct some search engine to help find local businesses based on some query. You can build some recommendation system that says, given some query or given some example business, show some other businesses that are similar to it. Because the Yelp Open Dataset has content about metropolitan areas. You could do something kind of fun or weird and say, well, if you like one metro area, you may like this other metro area. So build a recommendation system for that. You can cluster businesses into different genres, explore the clustering algorithms that we've talked about in class. You can work with Twitter. This is a lot of what I do to build recommender systems for friends, build models to predict Twitter engagement. So the RecSys challenge, RecSys is a conference on recommendation systems. Their challenge last year was building models for predicting Twitter engagement. If you do something like that, you can engage with these challenges and get a potential publication at the end, or at least attend some workshop. You can use Twitter to find COVID hotspots. I am actually a co-coordinator of the Trek incident streams task, where we use social media to rank content posted in the aftermath of disasters to help support emergency response officers. So you're welcome to use data from here to do things like identify volunteers or people who are willing to volunteer in the aftermath of crises, rank social media content by how critical it is that somebody sees it, recommend tweets that are likely to contain rumors for somebody who wants to do fact-checking or evaluation. Facebook does this actually, or it does a similar kind of thing. You can use some sports API to do things like predict sports team scores. This is what I did when I was much younger in my machine learning class. With the public APIs GitHub repo that I mentioned earlier on, or that I showed early on, there are a lot of APIs that you can use, some for transportation. So you can do like build a regression model for predicting flight prices based on content that you can pull from these APIs, plus content from a news site or something, predict or alert on traffic congestion. Google makes the Google Books API freely available, so you can use this to do book recommendations by pulling information about books. If you're interested in the stock market, there's a website called Alpha Vantage, or a company called Alpha Vantage. They have an API for doing stocks, and they actually have a free version of the API for educators and students. So if you are interested in doing stock market prediction, for example, let me know. And if you're interested in using Alpha Vantage, we can explore that. There's another Trek task called the Trek News task, where they're interested in doing recommendation around news articles. So giving you context for a particular news article, what other news articles might you want to read. So you might use this data to do author mining to figure out, who wrote a particular article, or do web crawling where you find other articles written by a given author, or recommend articles or authors based on some query or some example author. It's like, if you like author A, you'll also like author B, or if you like article A, here's 12 other articles you may read. I'll note sentiment analysis. I do not enjoy projects that are primarily geared around sentiment analysis. So I generally do not allow sentiment analysis projects. You are welcome to use sentiment analysis in your project, but your project must be more than just an analysis of sentiment. Sentiment analysis is a dangerous but appealing kind of analysis, because everybody has like an intuitive understanding of what sentiment analysis may be. Does content express some positive or negative attitude towards something, or some neutral attitude towards something? But the reality is sentiment analysis is very complex. You have to deal with things like negation. Sarcasm is really hard. But there are a lot of very easy libraries, or very accessible libraries, for doing sentiment analysis quickly and badly. So if you're going to do sentiment analysis, you have to be very careful about it. As a result, I tend to just say, do not do a project that's focused on sentiment analysis. If you're trying to do stock market prediction or flight prediction or something like that, like flight price prediction, sentiment analysis could be a useful signal, so you're welcome to use it, but the key point of your project, the useful insight, must not be sentiment analysis. It must be something more than that. So as I mentioned, any ideas that you have, please post them in the discussion forum. You'll get good feedback, and this will be a place if you want to work with or find fellow students to work with you. This will be a good place to do that. So yes, please post here. The last aspect of your course grade is about participation. So I have a couple of discussions already available on Canvas, and over the course of the semester we'll add more. So each module will likely have a set of discussion questions where I'll have a discussion board for that module and some questions that I want your feedback on, and you have to engage with your fellow students to answer some question that I've provided or share your feedback on some answer, or engage with your fellow students, because the engagement with your fellow students is a core part of learning. It's difficult to replicate in the online experience or the online environment, but this is how we'll do it, given that IS688 is a totally asynchronous course. All right, that's it for your introduction into the class. Some things to start working on for next week. So first, there's some readings. Specifically, read sections 1.1, 1.4, and 1.5 of Chapter 1. It should be very short. 1.1 is basically an overview of data mining. 1.4 and 1.5 are some review and outlines of the book. And 1.3 is a set of useful concepts that you should at least have some familiarity with. So if you can skim 1.3, if there's things that you're already familiar with everything in there, that's great. If you're not, read those a little bit more closely, because we'll use basically every concept that's in 1.3. Also, read Chapter 6, specifically sections 6.1 and 6.2. 6.1 is basically an introduction to frequent item set mining, which is going to be one of the early motivations we will have for data mining. And 6.2 is an algorithm for actually doing the frequent item set mining. It will be probably the most sophisticated kinds of math that we'll deal with over the course of the semester. Also, you need to sign up for Medium. Give me your Medium account name, because I'll be creating a course publication that will have all of us listed as contributors, so you can submit content to the Medium application when you submit your homework assignments. Do your introductions and start work on your semester projects or your project proposal. Please post in the Project Ideas forum. As I mentioned, this will be a good place for you to get feedback and engage with your fellow students to build teams. All right, so if you have any questions, by all means, post in the discussion forum, reach out to me via email, and welcome to 688.